Okay, welcome to my channel again. Today we're gonna talk about a Node-RED communication for Modbus. Make sure that you have installed a Node-RED and then Node.js module, of course. So okay, here we go. Okay, we have a flow one, and make sure that on your Node-RED you had installed some we call this a palette. Yeah, I had installed some module for Modbus, something like Modbus, this one, Node-RED Node-red-contrib.modbus. You can install from here. You can search a Modbus and you can hit install, and then the palette will become on the sidebar. In here you can find something like, yes, this one. So this is a Modbus element in here. For because of the VMware, I'm gonna test from the outside network from my Windows. I use a modsim, so I'm not gonna install the Wine for Ubuntu to run this application. Instead, I'm gonna run this from the Windows, and then this is a Modbus client app. So I will transmit from 505, something like that, but generally they use the port 502 or 503 or something like that. In this case I'm using 505, and then add new. This is a modsim. We're gonna need just a bit, maybe 10 registers only for holding registers. Okay, we will minimize it first, and then I'm gonna find the IP address for this Linux fconfig. Yeah, this one, 102.168.47.135, but this is a VMware, so it means that I had on my Windows as a host ipconfig. I'm gonna take the IP address from 192.168.47.1, something like that. Okay, so we'll open again this. So we're gonna take the Modbus read here. You can click and drag. First I'm gonna set, just double click and then set something in here. I call this Modbus read topic unit ID. This is a slave ID. You can found from here device ID, or you have another tools. Make sure the slave ID is same as or what we define in the Node-RED. I choose one only, and then the function code, I'm gonna choose read holding registers, and the address, the address, it meant where the address start from here, because of the Node-RED, this module defined from 0 base register, so it means that 0 base will be 4111 4001, I mean sorry, 41101, this one, and then next so it'll be index 0 1 0 1 2 3 4 5 6 7. So so we cannot only take for example 4 registers, something like that. So the address is 0, and then the quantity of course 4, and the pull rate we're gonna take 1 second. If you want to delay on start, so no problem, but we need to add new Modbus client in here. So the Modbus client from host, yeah, because my firmware is a guess. We're gonna choose the type is TCP, and then we're gonna set the IP is 102.168 1.1 if I'm not wrong. I'm gonna open again this, so this one, right, from the Windows 102.168.47.1, and I'm gonna keep this TCP type as a default. Okay, so in ID and timeout is 1000 milliseconds, so no problem. And I think so this kept default, the others add. So Modbus client from host is 2, and done. The first thing that we're going to do is we want to see the Modbus response for each this node and this node, the up and down node. So I'm going to connect, you're going to need to do this because you have to understand each response for each node from the Modbus read. Okay, so I'm gonna deploy this. Okay, I'm gonna name it something like the first node. Okay, so the maximum is 20, and the second is second node. Successfully some configuration. What is this? Okay. Okay, I'm gonna open the, so this, I'm gonna write something like date. We're gonna see in here, maybe there's something wrong in here, and okay, the port is wrong because I have defined it 4505, right, on the first time. We're gonna set this 505 and update, and then done. Just deploy. Okay, now connected. You see the each response from each node is quite different. You can see, and I'm gonna choose debug point in here. There's no debug because I'm not connected to the, I'm not connected each node to debug. Okay, if you want to see the response for each, also you can see from here. You can add to something like that. Name it the first out, and then this is this one is the second out. Then we get this output as a message dot payload. Okay, I connect this. I'm gonna need to connect this. Okay, so we here we can see the response for each node, right? 1 2 3 4 4 1 2 3 1 2 3. The buffer, this is a buffer also. So okay, let's we take each value from each register. So we'll split the value from each from each array, because it has a 4 array. You can see here 1 2 3 4 5, start from index 0 1 2. Okay, so I'm gonna put here. I'm gonna take from here. Let's see what is the difference. Okay, if we take from the first node from here, you can see from the first out. Oh, I just change the delay, something like 5 seconds maybe. Clear the nodes first. Okay, if you see here 1 2 3, we're gonna split this, but the message from the first node, first out from here, you can see it's quite different with this, with the second out. This is the data is stored on the data function, something like that. Okay, because of I take the I've connected the function from the first node. Okay, I'm gonna give a 4 array, split array, something like that, and then we're gonna write something like message 1. So this is kind of payload, message dot payload array 0, and for message 1 I'm gonna copy paste this script for easier to keep it easier. So I'm gonna copy this whole line and paste here. Okay, that's it. And return message, because we had 4 output, we're gonna send it as an array. So message 0, message 1, message 2, and message 3. Okay, okay, done. So we're gonna connect the output, the first out from here. We're gonna see the output from the function that we have written, and we're gonna deploy. So you can see here, this is going to take the first array, and this is the second array. So if I write something like 3 4 5 6 7, something like that, gotta take the second array will be stored at 3 4 5 6 7. See here. Okay, I'm going to change something like 3 4 5. You can see the response from here. Okay, now this is the value is 16-bit unsigned integer. Okay, so what if we want to take I'm gonna copy this function actually. What if I take the value from the second node from here? Okay, so because of the data the value stored on the data functions array, so we're gonna choose the payload dot data array 0. We have to read something like that. This is 1. This is 2. And this is 3. We'll do all the same. I'm going to copy this. For example, I'm connected to the third node from the output of a function, and third out. Okay, I'm deploy this. So I'm going to clear up this. So you can see the third out becomes 0 because I don't write any value from here. So if I change something like 2564, okay, you can see here the value change. Okay, so that's how you can take the value each register from the Modbus for the 16-bit unsigned integer. But how about the 32-bit value? Okay, but first I'm gonna take the value much easier to take from this node, from the first node of a Modbus read. So I'm gonna take another function here. First thing first. Okay, now we will see what is the output if we take a 32-bit value from here. So it means that I'm gonna keep it simple for message 0 maybe. If we only take the second register, the first two registers for 32-bit value. So I'm just keep it message 0, and if you want to take another value, you can say it message 1, something like that. I'm going to keep it the payload. So if I take the message payload, the first array value, and what we got here, no, it will be at each value, right? Try using something like shift bit. This is 16, and this. I'm gonna try this one. We're gonna take the first array is shift it 16-bit, and then we add the value from the second array. What will happen? 292555270. Okay, this is not the same like this. So if I swap, okay, this one, you see the value is 29250. I'm for just easier to make sure this one, I'm gonna keep it only the output is 292552705. Let's clean up. Okay, this one, right? So that swap, it means that the value is swapped. So if it's not swapped value, so we gonna change our script here from 1. We're gonna shift the second array 16-bit, and then we add the first array, so something like that. We're gonna see the value. What happened? You see now 7000. This is a 62-bit value, right? So if I wrote something 1 2 3 4 5 6 7, okay, that's good. Now what if the floating data, 32-bit, if I write something like floating point in here, I want to write 456.78. I want to show that value, this floating value shown here. we're gonna need something like float. Maybe this is by default it's just not available on the Node-RED, but you can add that a function or something like that from the palette, and you can install float. This one, Node-RED contrib float. Okay. There's another one, this one to float, but I don't know how to. I just use this because this is based on the IEEE 7754 floating point number. So we're gonna use this one to convert this 32-bit value that we have read from the Modbus registers to the floating value. So I'm gonna delete this one. I'm gonna connect this node, and the last one, this one. So this should be the value shown there. Okay, now you see here 5.4. This is same as we have entered from here, but the precision is more accurate there. You can adjust the accuracy from here. The decimal digits, maybe you want something like 5-digit decimal. So it means that if we write something like oh sorry, I'm opening Modbus modsim 12.12345, it will be read the value same as we entered in here. But if the value the decimal value more than 5 digits, so maybe something like this, the precisions come there 3, 4, 5, 7, 8, 9. Will be rounded to 5-digit decimal digit, right? So that's all, folks, from me. If you want to read the Modbus data on the Node-RED, so if you have any questions, please sorry, you can comment on the below. Okay, that's all, folks. I'm sorry, I'm kind of a mess here. Okay, that's all. Thank you for watching. Hope this will be helpful for you. Thanks a lot.